Anyway, so also welcome to everybody else. Actually, you guys have noticed the board. We have a document camera, but it's a modern document camera that's meant to look like a board. So when I write, it looks like I'm writing on the board. No, I'm kidding. No, it's just fooling around. We're going to be writing on document camera, so it's basically going to be that, but bigger. This I just did for fun, and I want to give you guys a nice welcome. So since most of you are new, welcome to all new anteaters. Okay, so what is this course about? Unless you're in the wrong room, you're intended to take calculus, calculus 1. So it's the first quarter in calculus. Many of you guys have probably seen calculus before at school. We're not going to assume that you know anything about calculus. We're going to assume that you only know pre-calc, and we're just going to go from there. So if you already know some calculus, more power to you, but we're still going to do it again, okay? We're going to be using this book, Stewart, 7th edition, okay? If you don't have it already, there's several options you have. You can buy the book. You can get the custom edition from UCI also. You can also get a DVD version, and any version works as long as it's 7th edition and as long as it's early transcendentals. There's the early transcendentals one and the other one. So it must say early transcendentals. Some people may have looked into or got the previous edition. The problem with that edition is that certain parts of it are different, like the numbers for the problems are different. So it's a different book in that sense. Oh, okay. So I recommend that you try and get the 7th edition if possible. If you already have the 6th edition, you can come and talk with me too. All right. We are going to be recorded for this course every single lecture, which is an interesting program. It's the UCI Opencourseware that has been going on for some time at UCI. I don't know if you guys know about the MIT Opencourseware. So if I understand right, UCI is right next to MIT on the size of this program. We have a lot of courses recorded. Pretty much the whole chemistry undergrad, or a large fraction of it, is already up online for anybody to see. Anybody, your parents, anybody can go there, show up, and take a look at the lectures. So we're going to be doing this with this course. And that means for you guys that if you ever, for some reason, couldn't come to class, you can always come later and check it out online. Okay, that's a good thing for the class. Hopefully you still come, right? But yeah, it's a very good service also for the other students who might not have taken Calculus 2A before and want to see it. So, okay, today we're going to be going over the syllabus, and also we're going to be talking some math. But I would first like to start with some math, and then maybe in half an hour or so we're going to talk about the syllabus. The syllabus has a lot of wrinkles, okay? So we will spend some time with the syllabus, but before, let's talk about functions. All right, this is the real screen, okay? It doesn't look like a board. So, what are functions? Have you guys heard of functions before? Sure, right? Okay. So, what are functions? That's a weird question, right? Have you guys wondered what a function is? You hear about functions all the time. Okay. So, any ideas? What do you think? Raise your hand. Tell me, what do you think is a function? Yes?
One x value only has one, or every x value only has one y value.
Okay. One x value only has one y value.
The other way around. Yeah.
The other way around. What else? In general, but also mathematically. Okay. So, okay, but you say what a function has as a property, but what is it? What is it? Is it a number? Is a function a number? It's a relation, actually. That's a very good technical term there. It's actually a relation. What else?
It's a process.
Process. I like that. I like process. Okay. So, yes?
Pardon.
A what? A part?
Pardon.
A
Pardon.
pardon?
Yes, do you record specific, like 1x equal, after some progress equal to another 1?
Yes.
It's a pardon to record something.
Program.
A program. Yes. Yes, exactly. That's right.
A rule.
A rule. I really like that. Okay, good. So we have different, I think we're narrowing down to some like real definition. And I really like your, what's your name?
Rebecca.
Rebecca. Is that your real name?
No.
What's your real name? Okay, Rebecca. I really like your definition. So I'm going to write that, okay? I'm sorry, I can practice your real name later, but right now I didn't get it. Okay, so a function is a rule that to every, let's see, element of a set D assigns exactly one element of a set E. Okay? So a rule, you can think about it as a machine or a process or a program. The idea is that you take the number x, you plug it into a machine or a rule or a program, and out comes f of x. Okay? So it's like, think about it as a factory. Like a number comes in, out comes the product. You know, after processing the number. Okay? So there's many different types of functions, and you can dream about different types of functions in any way you want. For example, suppose that this is the set D, and this is the set E. Suppose that you have a real number x, and then E could be something like x squared. Right? So to every number x, it squares it. In comes the number 2, out comes the number 4. In comes the number -3, out comes the number 9. But we don't have to talk about math necessarily. We can talk about the students in this room, for example. Students in this room, what could be a function that we could assign to every student in this room? What do you think? Homework? No. Maybe. No. You'd have to flesh it out a little more. Yes? Appearance. Okay. Yeah, I like that. For example, what about like a photo, right? So you take a photo. It would have to be a very, very specific way of taking the photo. You stand in a certain way, look at the camera, and then out comes the photo that is assigned to every student, right? So every student has a different photo. Okay, I like that. Yeah. Yes?
Student ID.
Your student ID, wonderful. I really like that. That has all the properties we want. Okay? For example, could a student have 2 student IDs? No, right? It's really just one that comes out. One student ID. Does every student have a student ID? Yes, right? Okay, I really like that example. Let me write it down. Student ID. Okay. What other function can we assign to the students in this room? A key. For what?
For the apartment.
For the apartment. Yes. Yes. I like that. Assuming you don't have two apartments. If you live just in one place, that's good. Let me write a key. I think key might be a little bit confusing. Okay, but let's write it down. The key. So apartment key. What about the height? Okay, each student has its own height, their own height, right? Can two students have the same height? Yes. Is that okay? Yes. Actually, yeah, it's okay. Yeah, two students can have the same height. Look, for example, at the function x squared. Minus 3 goes to 3, goes to 9. 3 goes to 9, and it's okay. Right? It doesn't. The only thing that it says is that to every element it assigns exactly one element of the other set. It doesn't say that two elements cannot have the same assignment. Okay. What's that?
Gender.
Gender. Yes. Yes, I like that. Gender. So the set D would be the set of all the students, and the set E would be the set of the two genders, male and female, right? Okay. We might also get more tricky, but you know, we're just going to leave it there. But let's see. For example, if you have the items in a store, for example, items in Walmart. And out comes the price. Each item has a price. Okay? So I'm going to point out two very important properties that are actually written in the definition of the function, but you may not have noticed explicitly. So these are the two properties that you're looking for. Notice the two things. One of them is that no element of D is left without function value. Another one is that no element in D can have more than one value. Okay, that's what we mean by exactly one. When I say exactly one, that's really what I mean. That it cannot be 2 and it cannot be 0. It's all contained in exactly one. The values, the number of every element has exactly one value, not 2 values, not 0 values, exactly one value. Okay, but it is okay to have for two different elements to have the same value. Okay, so what that means in the example of the key, which is an interesting example, is it okay for people to share an apartment? Can people share an apartment? Yes. That means that two different people can have the same key. That's still a function, right? But if somebody had two apartments, they would have two keys. That's not a function anymore. Okay? So there you go. That's the idea. You can come up with all kinds of examples, and every time you can wonder, is it a function or not? Now, we're going to be especially interested in functions that have mathematical meaning. So, for example, the function with the gender is fine, but it's not, you know, if it doesn't involve numbers, it's not that we're not interested, it's that we cannot really handle it mathematically as easily. So we're gonna start narrowing it down to functions that have numbers in them. Okay? numbers in, numbers out, for the most part, okay? It's going to get more complicated later in other courses. In this course, it's mostly going to be real numbers in, real numbers out, okay? Now, the question is, and this is the next thing we're going to be talking about, is how do we represent functions? How to represent a function. Okay, and can you guys see more or less what I'm writing? Is it more or less clear? More or less. Okay, I'm going to try and write as clearly as I can. Okay, now we're going to be talking about how to represent a function. But let me ask you first one last time. Do you guys, is it clear to you guys? I want it to be clear to everybody what a function is. Okay? Was it the example with the key? Was that understandable? Every person has their own key. Hopefully, all of you have some place to stay. So that means that every person has a key assigned to them, right? But you cannot have two keys. That would not be a function. But two people can have the same key. That's fine. Okay? Gender is the same thing. Two people can have the same gender. Okay? Or, for example, the height. Two people can have the same height. That's okay. All right. Another type of question, for example, suppose that, let's not make it more complicated and say that heights are just in inches, okay? So 5 feet 9 inches or 5 feet 10 inches, nothing in between. Does a function have to cover every single height to be a function? Does there have to be in the room somebody for every single possible height? No, right? That would be kind of hard, right? To have somebody with for every single height. Okay? So another thing that I'm not writing there is that not every single possible value of the is necessarily there. Not every single possible key belongs to somebody. Right? If you dream up a key, and it's okay if nobody has that key. Okay? Okay, so the first way to represent a function is what we call an arrow diagram. What is an arrow diagram? Well, it's the following. You take the set D and take the set E and put all the elements in a bag. So suppose that the set D consists of 5, 7, and 2. Okay? And we're going to put the elements of the set E in another bag. For example, 7, 9, 4, 3. And now we're going to have an arrow. That's why it's called an arrow diagram, right? So arrow that assigns to every element in D an element in E. Okay, well there you go. Let's look at the situation. The set D has 3 elements. Does every element have a value, an assigned value in E? Yes, right? Does it have exactly one value assigned in E? Yes. That's all you need to check. Everything else is gravy. In this case, for example, is it okay for 2 elements to go to the same value? Yes. Is it okay that the number 3 there is missing with nobody going there? Yes. So it's a function. All right. If you had 2 arrows coming out of the same guy, that would be a problem, right? But right now, this is okay. All right. So you guys are going to be looking at some other arrow diagrams as homework. I'm going to do this so that you can still see what we had before. A second way to represent a function. What do you guys think? Any ideas on how else you can represent a function?
T-chart.
What is it?
T-chart.
A chart? Like a table?
Yes.
Yes, I like that.
Graph.
Or a graph. Or what else? Formula. Expression. Yes, I like that. Okay, first, let's talk about the chart. So the second one is a chart or a table. So for example, if we're talking about the function that to every student assigns their student ID, for example, like you were suggesting, I think, right? So, so name, and then the student ID. So here, for example, is Peter, and the student ID is, I don't know, 74532. Okay, that's the student ID. I mean, I know it's longer, but let's just make it like that. Mary has the student ID 13749. And so on and so forth. You make a list of as many students as you want and their corresponding student ID. That's a little bit more systematic than having to draw things into a bubble and drawing arrows, okay? But it's basically the same thing. And you'll be seeing that in the course. The first one is a little bit more like primary school. Here we're getting more into like middle school, okay? So you can see for every person, for every element in D, you can see their assigned value. And implicitly in the chart is the fact that you cannot have more than one and you cannot have 0. You have to have 1. So there you go, very convenient. But what's the problem with that, actually with both of those? Well, what do you think is the problem with both of those things we've talked about so far? Yes?
How we got to the answer. They don't really explain how we get.
Well, actually, okay, good point. Good point. If there's a systematic way to do it, that's fine. But the definition of the function does not call for a systematic way. It could be completely arbitrary. In fact, the book gives another example. You know, when you send a letter to the post office, the person at the post office knows exactly how much it will cost to ship, right? Is there a simple like formula to write to calculate it? No, it's really a table. It's a chart. If the weight, say by weight, if the weight is less than so and so much, then this is the price. If the weight is so and so much, then that's the price, okay? There doesn't have to be a procedure to do it. It's just a table, right? Or how much tax you pay, okay? There's a table saying, okay, if it's between this and this, you pay so much, so on and so forth. It doesn't have to be a formula, okay? But what is the problem with this particular table? That to every single element assigns the value, yes?
What if they have infinitive values?
Ah, excellent. Excellent. What if there's infinitely many elements in D? Okay? So then you would never finish writing the table. Right? You would never learn calculus. Yes?
Limits and end behavior?
Sorry?
Limits and end behavior?
Yes, we could talk about limits. Limits involve infinity too. In this case, it's just a practical problem. You would never be done. Okay? So what do we do with infinite sets D? Okay? So problem, as you well pointed out, what about infinite sets D? Okay, so now we get into one of the more efficient, really one of the more efficient ways to display a function. And you guys also brought it up already, and that is that of a graph. Okay? So a graph works as follows. And I know you guys have probably seen it before, but I'm still going to tell you. You put here the x values. For example, 1, 2, 3, and so on and so forth. And you put here the y values, 1, 2, 3. What do I mean by x values and y values? Well, I'll tell you in a moment. And you draw a graph. Okay? How do you interpret that graph? Well, for example, the point 3, if you take the point 3 and you follow it vertically, it goes to the point 2. Okay? So 3, 2 can be interpreted in the following way. It means that the function, the machine, takes the number 3 and spits out the number 2. Okay? That's what it means. So it means x, f of x. And from this pair you can read the value of the input and the value of the output. So if you take any value for the input and you want to know the value of the output, you just follow it vertically. Okay? What is the advantage of that over a table? Well, as you can see, in just one stroke, just by drawing it once in a moment, I already drew infinitely many function values. Amazing, right? That was very efficient. It would have taken me forever. I would have never finished because there's infinitely many real numbers. There's even infinitely many numbers between 0 and 5, the ones that I drew over there. You see the advantage, right? Great, awesome. So now, does it have to be a formula again for the function that I drew? Well, no, it's just a line. Any line that I drew, it doesn't even have to be a line, but let's not get there. I mean, for example, I could have a line that's broken into 2, right? That would still be a function if you draw it right. But let's just for the moment talk about lines, okay? For every point on the x-axis, there's one point in the y-axis, that's the value. Now, how do you know if a given graph is actually a function or not? Yes? That's right. Have you guys heard about the vertical line test? Yes. Well, some of you may have heard about it. The idea is that the graph, what? What is the vertical line test?
Well, we should have 2 y's for 1 x.
Exactly. If you draw a vertical line anywhere, then what? You should not touch 2 points. That's right. If you draw any vertical line, you should only touch the graph once. Because if you touched it twice, it means that the same x would have 2 y's, right? Exactly. So we have to satisfy the vertical line test. Each vertical line over the set D can only intersect the graph once. We're running out of time to talk about the syllabus, so I'm going to try and finish quick. All right, so for example, if it did something like, if it went there and then back like this, then it would be intersected twice. Right? This is the vertical line. I'm not going to draw it just not to mess up the graph. But for example, this kind of graph would, what do you think? Is it okay or is not okay? Right, it depends what you mean by okay, right? It's not okay in the sense that it's not a function. But this one like this is okay. It doesn't matter where you draw the line. There's only one intersection. Okay. Now we can talk about the fourth way to describe a function? And you guys have already mentioned it. What is it? Equation, formula, equation. Let's write formula. Okay. That is probably the most efficient way to do it, if there is one. I mean, if there's a formula for it, it's a very efficient way to describe it. For example, if you write the equation f of x equals x squared, what does that mean? Yes? Yes, and that value is what? Right, that's right. So, very good point. What's in here, this x right here, is the input. And input in D. Okay, that's the input. And this thing here is the value. Okay. So what does that mean? Right? In just one formula, just one line that I write there, I can already say, okay, minus 2 goes to 4. 3 goes to 9. 4 goes to 16. I can plug in any number x and out comes x squared. Okay? It's more efficient than a table. It's more efficient than an arrow diagram. And it's also more efficient than a graph in the sense that, what if I try to draw a graph for the function x squared? What would happen in that case? It's a parabola, yes, but could I draw the whole thing? No. I cannot draw the whole thing. I would run out of board, right? At some point I cannot continue to draw because I ran out of board. This formula does not have that problem. You see? You never run out of board. No matter how large x, I can tell you what is the value x squared. Okay? So, very efficient. It doesn't always work, of course. For example, for the case of the postal worker, there may or may not be an actual formula. You may need to make do with a graph, with a table. Okay? But when there is a formula, it's a very efficient way to describe a function. Okay, do you guys have any questions? No questions? Okay, I'm going to tell you one last thing and then we're going to move over to the syllabus. The syllabus, okay? And now that we're talking about functions, I'm going to tell you about a special type of function which is called a piecewise defined function. Piecewise defined function. Sometimes you almost have a formula, but you don't quite. How come you almost have a formula, but not quite? For example, suppose that we go back to the example with the taxes, okay? No two people have exactly the same income. I mean, in principle, there's such a wide range. Well, okay, fine. So two people can have the same income, fine, yes. But there's not exactly a table. There's more like a formula, right? That for every, you grab the income, you multiply by so and so much, calculate so and so much percent, that's how much tax you have to pay. But if the income is in a certain range, it's one formula. If the income is in another certain range, it's a different formula. Okay? I don't know how many of you guys have done your own taxes, so maybe I'm not sure it's the best example. Okay, no, that was not a question, never mind. But the point is, sometimes there's more than one formula in the same function, depending on the range. So, for example, you could have a function that has the formula x squared for x bigger or equal than 0, and the value 1 for x less than 0. That is also a function, right? Once again, for every input x, you know exactly, you have one output, and you only have one output, exactly one. Because the number is either bigger or equal than 0 or less than 0. It cannot be both at the same time. What would be the graph of this function? It would be a funny graph, but it's okay. So this is x, this is y. How would that work? Well, for x bigger or equal than 0, it would be a parabola, something like this. Actually, never mind, it's a little different, but never mind the details of the actual values. But for x bigger than 0, it's a parabola. Yeah, well, let's see. So, here, I got it. Hold on. All right, so this is 1, and this is 1. Okay? And this is 1/2, and so on and so forth. So it's a parabola. Okay? But what happens when x is less than 0? Then the function has always value 1, right? Which is right here. Okay. What do we do at 0? Well, we're getting there. But what happens at 0? Is 0 less than 0? No. It's bigger or equal than 0, right? So f of 0 is what? F of 0 is 0. Do you guys agree? The rest of you? Yes. It's 0. So how do we specify in this graph that the value at the point 0 is 0? Because if you just look at the graph, you cannot see it. Okay, so you draw circles. You draw an empty circle over here saying that it's 1, 1, 1, 1, 1, but not at 0. And you draw a full circle here indicating that the function has value 0 at 0. Okay, great. Now we can talk about the syllabus. Oh, actually, one more thing, which I forgot to say. The sets D and E actually have names. What are the names of those? Okay, especially the set D. The set D has an important name. What is it called? Domain. That's right. Okay, the set E. What about the E? Well, okay, it can get a little bit tricky, but sorry. You can talk about the range, or you can talk about the codomain. Actually, the term codomain is a little more precise. Sometimes we use range, and it depends, and we're not going to talk about it now because it's something more technical. So instead, I'm going to ask you, do you have any other questions? Okay, remember, we're not done yet. We still have 10 more minutes, right? So we're going to talk about the syllabus. Actually, you know what? Let me not give you two different names. Let's just stick with codomain. Okay? We'll talk about the range later, okay? All right. So okay, so who has already downloaded and looked at the syllabus? Raise your hand. Okay, not so many of you. All right, so we're going to go over it. Maybe I'm not sure if I'm going to have time to read the whole thing, but I'm going to read the premise. So, in this course, you will learn the most basic concepts of differential calculus, which you will find useful in almost any scientific area, whether you're an engineer, an economist, even a social scientist, or even in the humanities. I'm not sure, but like if you're a political scientist, any kind of scientific endeavor, you're probably going to find calculus very useful. Biology, okay. The main idea is that of a derivative. You guys may have heard of derivatives before. That's going to be the central concept of the course. Derivatives. Okay, what is a derivative? Well, the derivative, to spoil the surprise, the derivative is a function that describes how another function is changing. Okay? Right? Surprising, no? Anyway, that probably doesn't make any sense right now. We're going to talk about that in detail. Yes?
It's a slope.
It has to do with the slope. That's right. Graphically, it's a slope. Right? That's going to be the central concept for the course. Now, around the course, first we have to explain a few things to understand what we need to know for understanding the concept, and then we're going to use the concept. We're going to apply. Okay? So, we first will talk about various special functions such as sine, cosine, exponential functions, and the concept of a limit, which somebody already brought up. And then we're going to lead up to derivatives. Then we will use derivatives in various applications, okay? And that includes modeling exponential growth, estimating errors in functions. Sometimes you don't know exactly the value of x, but you know the function. You want to find out f of x, you can use derivatives. And optimizing functions. Sometimes you want to know the maximum of a function or the minimum, okay? That can be very important to, for example, optimize productivity in a factory. If you have a factory of chairs, you want to know how many chairs you should be making to optimize your profit, you can use calculus. Okay. There's going to be 2 midterm exams. There's going to be quizzes every week. And there will be a final exam. There's also something called web work. If you guys have not been at UCI before, you probably haven't heard of web work before. Web work is something like a homework, like a graded homework, but it's not graded by a human. It's graded by a computer. What it means is that it's personalized. You log into a computer page. It tells you a particular set of problems that are especially designed for you. The numbers are only for you. If the student next seat is going to get a different set of numbers, and you're supposed to figure out how the problem works and give the answer. You can try as many times as you want to solve it, okay? If it takes you 10 tries, that's okay, as long as you get it right at some point. Ideally, you shouldn't just guess around, but you should know the answer and then write it. That's the plan. There's going to be one every week, starting in the 2nd or 3rd week, okay? Not right now, so don't worry about it for now. And the lowest grade will be dropped. Now, there's also a number of quizzes, and we're also going to drop the lowest quiz. So if for some reason during the quarter, somebody in your family, God forbid, passes away, or you have a problem, or you really couldn't make it, that's okay, that grade gets dropped. That means you're not handicapped in any way with respect to your classmates, okay? So, quiz assignments. Oh, and this is the percentages, right? Quiz assignments. There's going to be a quiz every week on Tuesday, okay? And the quiz on Tuesday covers the material from the previous week. So, for example, suppose this had been a normal lecture week, Monday, Wednesday, Friday this week. I know it's not. We just started today. Suppose we had lecture Monday, Wednesday, Friday. This coming Tuesday, there will be a quiz covering the lectures from this week, Monday, Wednesday, Friday. Okay? So those are the lectures that are covered in the quiz. There's going to be a quiz pretty much every week except right before the exam or right before the final exam. You might want to spend some additional time talking about the exam. Okay, homework. You guys may have been really good in math in high school, but you will find that this course in college moves a lot faster than in high school. Okay, I found that I experienced that as a student very much. You have to really raise your level of study to keep up in college. Okay, and the way that I find, not only me but in general, that students learn the best is by doing. So just coming to class and trying to pay attention is really not enough for this kind of things that we're going to do. Really, the best thing to do, what I recommend you to do, is to sit down with the book and actually do problems. Okay? So, those problems, because we're going to have the web work, those problems that are assigned are just assigned for you. We're not going to grade them for you. As an incentive for you to actually do the homework, the quiz will have usually 2 questions every week, and one of the 2 questions will be basically from the homework. Okay, so if you do the homework problems, it's going to be easy because you've already done it. Once you've done it before a math problem, you always remember it. You just do it again. Okay, so that's your incentive to do the homework problems, but really, it should be a preparation for you to drill for the exam and to really understand the material. More practically, as another incentive, if you don't understand the material because you didn't do enough practice, you're going to have a hard time in the midterm, okay? So, midterm and final exams. You should bring your ID the day of the exam. You may not use any calculators, cell phones, iPhones, or anything that beeps. Grades of exams are expected to lie in the C range. So if everybody does really badly, in an exceptional case that everybody does really badly, we can raise everybody's grades a little bit. That's what in the US we call a curve, okay? I'm going to hear a lot about curves this quarter, more than I would prefer to. Ideally, there shouldn't be one, but if people do really badly for some reason, we'll make sure that not everybody has a bad grade. But in general, this should not be a curve. There should not be a need for a curve. Okay, we're going to have the standard way to determine the grades, which you can see here, a table. There you go. It's a function, right? It's a function that to every grade assigns a letter, either A, B, C, and so forth. Okay, the midterm dates are here. By the way, be careful if you downloaded the syllabus 3 or 4 days ago or before, because the dates have been changed. It used to be November 13th, now it's November 15th. Sorry. Oh. Okay, we're almost done. So, all right, great. The first quiz assignment is special. It's not a normal quiz. That's going to be the quiz for Tuesday next week because we didn't have any lectures. I mean, in principle, we could do a quiz about today, but we're not going to do that. Instead, I'm going to ask you for a special procedure. The first part of the procedure, well, actually, there's 3 parts. And when you do all 3 parts, they're essentially surveys and forms. When you do them, all those 3 things will constitute the grade for your first quiz. Okay? That quiz is going to be worth maybe 3% of your grade, so it's not that big a deal for the whole course. But it is a quiz. I mean, it would lower your grade if you don't do it. I mean, it's encouraged for you to do. The first part is something that I would like you to do to find out more about you. Okay? It's an easy form to fill. Basically, it contains student bio information, your name, what you like about mathematics, what you're expecting from the course, and a photo. I would like to be able to see a photo of you so that I can remember you later if you show up in the office hour, or if you ask a question. I mean, it's going to be a lot of students, but I'm going to try to learn a few names if I can. So I would like to have your photo, if you don't mind. Okay, fine. Yeah, okay, fine, photo. Okay, that's the first part. You don't need to turn it in by Tuesday. You can turn it in any time in the next few weeks before the first midterm, which is, I think, October 23rd. So anytime between now and October 23rd, you come to my office hour and you turn it in to me. Why to my office hour? So you could argue, well, why don't you just give it to me now, or give it to me in the end of class? Another purpose of this assignment is for you to find out where my office is, believe it or not. Why? Because a lot of times people don't go to office hours because they don't know where the office hour is, right? So I would like you guys to find out about my office so that next time when you actually have a question about math, you can come and ask me directly. Okay? So that's the first part. The second part is just a survey that you'll receive on IEEE by email. You fill out the survey about practices of how you learn calculus, what you expect from the course, and you turn it in, also online. That's part of an instructional program that is basically research that we're doing to learn how students are learning. Okay, web work we already talked about. Opencourseware is what we just mentioned before, is that every single lecture will be recorded. Okay, and now there is also something called LARC. It's a program that's designed to give you special personalized assistance. So if you're falling behind, if you're feeling like you're struggling in the course, you can go to LARC. I think it takes place about twice a week, and you can get lessons there. Now, the lessons there are not free. You have to pay, but it's very cheap if you consider what you can get. What you can get is, I think it's $100 for the whole quarter, right? Because you pay by the quarter, you should think now if you're interested in it, because then that way if you sign up early, you get more out of it, okay? So it may be worth investing in it. There's also something else in the math department has a tutoring center. I'm not sure exactly what the difference is between the two. Probably more restricted, the tutoring center. Tutoring center is free. So you can show up to the math department at a given time and ask questions about the class. That's also available. There's a link to that in the website. And that's it. Oh, actually, this is the actual sections we're going to cover every day from the book. These are the suggested homework problems. Okay? And that's it. That's the syllabus.